questions. So instead, here's my goal. We're going to start right away in the notes. We're going to finish those examples that we just got to start at the end of yesterday. Then we're going to cover the one new idea. And my hope is that we can start on homework. So we're starting right away on examples. I have one quick little thing to teach you today besides examples. A couple more examples, and then hopefully we can do examples. Enough examples that you guys feel confident in starting your homework. Maybe you're starting homework 62? That's not 61. 62, right?
Yeah.
61 last time?
Yeah.
60 dose. What? That's some Spanglish going on. All right. Okay. So thank you guys for listening. So we have a way to. Thank you. All right, here we go. The recorder started. I'm ready to go. Let's just jump straight in. Let's do some math. Let's see the one danger, the one pitfall that we have to watch out for. It's the second half of homework 62, the second half of section 10.3, I should say. We have to watch out for one danger, one pitfall, one landmine that we've got to be careful not to step on in these problems. But otherwise, here we go. Notes open. If you don't take notes, you should have at least a scratch piece of paper that you can play around with examples on.
Just like a round piece of paper.
And remember, our test is next Tuesday. Since our test is next Tuesday, you have to have your notes ready to go. Now, listen carefully. On last test, chapter 9, I would say a third of you didn't turn in notes. You got a 0. You got an F on a notes grade, which affects your grade and drags it down. So if... I'm not sure if notes have been put in yet.
I've turned in my notes, but I still got a 0. And I have
Right now is not a grade time, but you can stay in during lunch and you can look at the grade book, okay? I haven't updated RegWeb yet this week. It was updated the end of last week, so it might be. Well, let me see. If you guys ever don't get your notes turned in, or if you are absent and you turn them in later, you can turn them in during lunch or after school. Just let me see them real quick, write them down. And if they're late, I can still give you half credit. So if any of you guys have missing notes, go online to my website. How do you get there? tinyurl.com/do-math. Didn't you write that down? I had to.
Yeah, I wrote it down.
And it's on RegWeb. The link to my website. I think I have a couple places that link to my website.
Yeah.
Go to RegWeb, click on it, and get there. All right, here we go. I know your heads might be cold, that's why I let you put your hoods on, but your hands, they gotta start moving. Otherwise, they're gonna freeze up. Don't want frostbite, so let's go ahead and start writing notes. Here we go. So rub them
Now I want them.
in our.
It's not like you take it.
Here we go. Kiddos, we had some ... yesterday that we did not.
No, okay.
What?
You're right.
Raise your hand next time. Okay. Yesterday we had some ... that we need to finish, but can you guys remind me? I think that you were just looking at this, so can I just really quickly clear the whole page? And we're going to start again. So, you guys don't even need to write a heading, just go straight on where we left off yesterday. Go right there. Okay? Example. Example number 3. Go straight to where we left off yesterday. Do you see radicals in these equations?
Yes.
Good, me too. How do we, in number 3, get the example written down? How do we get rid of the radical if it's a square root? Okay. So we square the left side, and what we do to one side?
You do the other.
And what's weird, maybe it's not that weird, but what's weird in this one is that they both had radicals. The left side had a radical, the right side had a radical. So the nice thing is, just like Johnny's saying, a radical, a square root with a squared, a square root with a square, they cancel out. And it makes the solving process so much easier, because what's left on the left-hand side?
Yeah.
Getting it down? What's left on the right-hand side?
Oh, it's getting hurt.
Now, what we didn't do yesterday was actually get to the end. The end is x equals maybe 1, maybe 2. It depends on whether it's quadratic or not. How do we get x alone? Yeah, we move it to the other side, but Jordan, how?
So you do subtract 1, so 3x equals 4.
You could subtract 1. Okay, do that first.
And then you subtract.
Aiden and Jay, why are we talking? Because I don't think you're doing math right this second, so let's go ahead and be quiet and focus. 3x is equal to 4x. What's negative 7 minus 1?
Negative.
Negative 8.
So then you subtract 4x, so then you have negative 1x equals negative 8, and then you divide by the negative x equals 0.
So the goal if you have x's on both sides, I think that's probably like a section or even maybe a chapter from last semester. Not this semester, last semester. So you have x's on both sides, and you get all the x terms on one side, which we're doing right here. We got them all on the left and combined. And get all the numbers without x's on the right-hand side, which we did as well. Now, if you notice, the x is still not alone, which is why Jordan said, hey, there's one more step. Can you guys see that one more step?
Divide by
Yeah.
negative.
Divide by a negative 1. That'll do it. A negative over a negative is a positive x. But what I do to one side, I have to do to the other. A negative 8 over a negative 1 is a negative over a negative 1. Positive. So we were almost there yesterday, guys. We just needed like 2 more minutes, but that's okay. We saw yesterday, if you have a radical already in an equation, you need to get a power, a squared in if it's a square root. But what's different about number 4?
It's a cube root.
It's a cube root. Remember how we call it? Square root versus cube root? That's a cube root. And so instead of raising it to the second power, which we say, this is called squaring. We need to go ahead and look at that, and we need to cube it instead. That works. Raising it to the third power is another snazzy way of saying it. So what we need to do on the left is raise that whole expression to the third power.
And then do that on the right side.
So
And in algebra, what you do on the left, you do on the... Yeah. Now, does anybody have their calculator close? I did this yesterday for you, but I want to make sure you can do it for yourselves. What don't you understand? Go ahead, ask the question.
it's 30, it's 330.
Cubit?
Why?
Is there a cube on the left?
Exactly.
Okay.
Now, why do we square it? Because if there's nothing in the radical, what do we call it? A square root. Does that make sense? Okay. So with the square root, we square. With the cube root, with the little 3 in the index, we need to cube it. Yeah. Oh, no, Jordan's trying to do the next side, but something went wrong. Something went wrong. But you're right, Caleb, in that the cubed and the cubed root cancel out. So he was saying, hey, it's just 3c plus 7, and he's right. Equals. How do we do 10 cubed?
It's 330.
Nope. The other way.
Or the final answer.
Size of 1,000. Oh, final answer. Okay, you're ahead. In 10 cubed, you guys can do it a few ways. In some of your calculators, you might have something that looks like a carrot.
Whoa.
There might be something that looks like a carrot in some of your calculators. Angel, do you see a carrot in yours? Yeah. Okay. A carrot, you can do 10 caret 3, and you're raising 10 to the third power. But that's also the same thing as just doing 10 times 10 times 10. So depending on your calculator, yeah. There are different ways of solving it. But Ian, do you think you can do this on your calculator?
I don't have a calculator, but if I have them.
But you understand what I'm telling you.
Yeah.
Cool. So then, Angel's already done that. And 10 times 10 times 10 is 1,000.
So shy.
So then we do have 3c plus 7 equals 1,000. Johnny's already saying, like, hey, we need to keep solving. And he's right. We have to subtract 7.
Then
And divide by 3. Yeah, some of you guys are already seeing the steps to getting C1.
get.
I think you got 993, right? So then, Tyler, what's 993 divided by 3? Do you have a calculator back there you can use?
I don't.
331.
Okay, we got it, 331. That one's kind of harder to do. But guys, you actually could have him if you, for instance, might be in a math class in your college someday. Some college professors say calculators are for the weak. Not literally, but they basically say it is our job, wait, pause, it is our job, college professors, it is our job to make you better at the basics of math. And they say absolutely no calculators. Now, they don't always say that for every single class, but for a lot of math classes that you ever did have to take one. So I'm just trying to remind you guys that you could have done this by hand
mean, you can see it
Old
three goes
school.
in the 3 one time per year.
Some people can see it.
Or I could.
Some people can't. Some people can't though. That's why I'm doing this. But I'm just trying to remind you with long division, you could have seen that 3 goes into 9 3 times. 3 goes into 9 3 times. So we have, oh, except I can't actually divide because that's 3 times what is 9? 30. And 1. Right? So you could have done that by hand if you needed to. And Tyler, you should just stop protecting Jordan, or if it's the other way around, let's just stop. Alright, cool kids. Thank you for letting me get through those 2 examples. What was the difference between 3 and 4 and how we solved?
We had
Well,
we
you
used cube root.
We used,
cube
well, 3 did have a square root, and 4 did have a cube root. I need you guys to use the words right. What did we put into number 3? We squared, not root. We squared. Good. And what did we do on number 4? We cubed both sides. There was a cube root. You needed to cube it. Okay, so I'm going to give you guys a challenge problem. You guys ready? Here we go. I'm going to give you a challenge problem. It's actually harder than any of the homework ones I gave you last night. Because it was like at the end of the section, I was like, oh, I'll save that one for us to try in class. So I want you guys right now, you yourselves in your paper, I want you to see if you can get all the way to the answer, not telling me any steps, working very carefully to see if you can solve for the variable in this problem. Can you find C? Ready, set, carefully, pretend this was a little quiz, write it down. Can you do any or get any of the right steps? Rob, go ahead and do that. Tyler, you two just for a second.
I was trying.
Oh, okay, but you're gonna not touch it?
Yeah.
Okay. Pretend this was a little pop quiz. Could you get all the way there, step by step? Okay, write it down first. Or if they can tell you the first step is getting it written down correctly. Sometimes they write it down wrong and it messes them all up. Who else has it?
Sorry, I'm gonna
Give me a second.
I'm gonna
Not yet.
Okay.
add, since there's already an 11 over, I'm gonna add 11.
No. Subtract 3 up.
Oh, okay. So it's not
First you subtract
and then where do you put this?
11. Huh?
Oh, 19 a number?
That-
Oh, is that?
And then bring it to the
Oh,
other
okay.
side.
That is number 19.
Yep.
Alright, and then once you do
If you guys finish, you can.
Oh, okay.
You get this one.
Nope. What's your first step?
I do that. I just did. First thing I do is maximize.
No, you subtract 19 from the right. Because you have, you want to keep the square root by itself. Yeah. Just like this.
I like how you were trying to.
This is medicine.
Oh, I started that's
Four is Yeah.
Oh,
Yeah.
God bless.
Yeah.
Young. That's all.
Alright. So if you guys were able to get fairly far,
That's all.
Y'all.
So that's what I was about to drop.
Make sure drop you over.
so you
Hey,
got
that's right there.
Justine.
Is it curly? Well, I'm just kidding. My sister's there. It's curly. Tyler. I like it, bro. Like chilies.
Alright. Alright, grab a seat, kiddos. Let me go ahead and walk you through. Some of you guys got here before me, and if you did, you should be writing down your homework assignment for tonight. If you didn't finish it, or if you're not sure if you got it right, the correct answer was 5, but the point is not the answer. The point is, can you do the process?
Yes.
So, some of you missed that this was, you had to write down. Some of you missed, Bob, did you focus on it? Some of you missed that this was the whole problem. So first of all, I do want to square the radical, but he's not by himself. I can't do it yet. I have to get him alone. So those of you guys that were able to start the problem, what was the first thing you had to do?
Subtract 19.
Yeah. These are not allowed to go together because they are not in parentheses. They can't go
Oh,
together.
wait.
4 is being multiplied by the root, so I have to get rid of the 19
You're not
first.
supposed to do
-8.
Angel, I need you to track these. This is kind of hard.
Yes. -8.
Are you fixing the problem on your paper? Guys, thank you for all the participation. Let's pause and make sure everyone's focused. We're wasting time. So 11 minus 19, some of you are trying to help out, and thank you. It is -8. Why is John saying division?
Because you have to keep dividing.
I have to get rid of the -4. Good. I have to get rid of the -4 next. So I have to divide both sides by -4.
So, let's see if you put +4, it'd be wrong.
Yeah, because I have to divide. It's
How do you know when to do?
Well, you have to look at the numbers.
Because if it's by itself.
Since
Okay.
it's next to, that's times. I had to undo times. I have to divide. All right. So what is -8?
2.
2.
-8 divided by -4 is +2. I have the square root of 3c minus 11. Now I have a square root. He's on his own. He's alone. And it's prime time to say, all right, let's go ahead and undo by
3c minus
square.
11 equals 4.
Good. Once again, if you guys have finished the example, if you know the answer is 5, you can be writing down your homework.
Is this what the
So if I knew the answer was 5, I would do it.
2 squared is 4. If you knew it was 5, then that's good, honey. You should be writing this.
I'll do that.
I said get down, I don't written down. There's just still.
Kiddos, I'm still explaining to a few of your classmates. They're talking here and here and there and there. I have 3c equals what? 15. And I need to divide. C equals 5.
Yeah.
Go ahead. Rob, when Dylan comes back, you may run to the restroom quickly. Can't do that. I know it looks like it. I know, but you can't put it together unless there's parentheses.
I know. Still got the same.
You got 5.
No.
19 minus 4 would be 15, and you would have had to divide. So I bet you accidentally did some subtraction. So you kind of did like 2 negatives to make a positive. You did 2 illegals, and it magically worked.
I was just thinking.
But no, don't. It's not gonna work every time. All right, cool kids. With that, 12.
12:15. 15.
It's okay, it's for me. It's not gonna be
Can't
like
get out.
Why are you
calm. I'm not leaving. Just quiet.
Why are you
I don't mean. My calculus kids are taking a big test in the gym. She let me know when they will be done, so that I can expect them to be done. Let's just come back and finish the lesson, because once they're done, they're gonna come running in here and they're gonna distract you guys. Let's get you guys on homework. Okay? Here we go. We need to finish the lesson. So, the beginning of homework, guys. 23, 26, 29, 30. Actually, the beginning of homework, Johnny, shush. Please, just let me get something done. Okay, where does homework start? I need you to look at this for me. Alright, I'm done. Absolute silence. No raising of hands, no answering of questions, nothing. Absolute silence for the rest of class until I let you guys do homework. Because you're just wasting all of our time. I want you guys to look at the homework up here, and when I ask a question, still don't answer it. Nothing. No words come out of your mouth. Okay, here we go. If you look at homework, no words come out of your mouth. No hands raised unless something's cut off and bleeding. And don't do that just to raise your hand and talk. In the first beginning of homework, 23 and 26 asks us actually to not even solve. It says use the graph to solve. If you're using the graph to solve, when do two equations equal each other? We're looking for intersections. We're looking for intersections. So, let me not do your homework 23. No words. They'll be fine without a blessing. You can think it in your heart. So, let's look at number 24 really fast, okay? If I was looking for the answer to number 24, all I'm looking for is the intersection. So where does 24, where do these two equations intersect? 5 and 4. But what's the only variable I'm looking for? X. Okay, back to quiet. So in number 24, you find a point where they intersect. It intersects at 5, 4. It intersects at 5, 4, and I just say x equals 5. That's the answer. All I need is the x. Okay, but after this part of homework, then we go to numbers 29 and 30. And kiddos, no talking. 29 and 30, the direction says solve. You can just nod your head, no words. Don't these look like what we were just doing? Okay. These look like what we were just doing. So the beginning of homework is finishing up kind of what we did yesterday. But then homework comes down to number 37. And 41. 37 and 41. Wait, this kind of looks like what we were doing. I want you guys to hold up with your fingers. What power do I need to raise these radicals to get rid of them? The third power. Good. Hands down. Good job. Let's come back. So we're still kind of on the end of yesterday's lesson, the harder problems. We have to raise to the third power. This is what's new. So everyone, eyes up here. This is what's new. No more hand motions. This is what's new, the word extraneous. Now, I think you guys have seen it earlier this year, but these two sections, I have 45 to 55 odds, so that you can check your answers and come tomorrow with ones that you didn't understand even after checking. We need to learn the word extraneous. So here's how we're going to do it. Let's get back to our notes. We're going to do one problem that actually looks really easy. I don't know about you guys, but this problem looks easier than some of the ones we've done. Now, write it down. It's okay. It's good. We gotta stay focused. This problem looks a little bit easier than some of the ones we were doing. So why does it start at the end of homework, which is usually the harder stuff? And this new word, extraneous. 10.3 part 2 is on the board. How would you guys solve? Hold up with your fingers. What power would you raise both sides to? Good. The squared power. So we would raise both sides to the second power. We would square both sides. Right? And when we square, you guys don't need the answer, just go ahead and look. Do you remember the square root and the square is going to cancel? The x remains, and what do we get on the other side? Well, negative 2 times negative 2 is positive 4. Now, usually I would say, awesome job, box it, you're done. But the problem is, wait, the answer is no solution. Now here's what's weird. We got an answer. This introduces the idea of extraneous. Kiddos, look at the beginning equation. If you were to take the square root of positive 4, it could have been positive 2, but not negative. If you were to take the square root of negative 4, actually, that doesn't exist. Remember, there isn't one. If you take the square root of a positive 4, it could be plus or minus 2. No, it can't be unless there's a plus or minus we're putting in. Here's the weird thing. We just started solving without asking ourselves the question, can we get a square root to ever be a negative? And the answer is no, because you can't have a negative under a square root. So a negative will never come out. Now, how can we guard against this danger of the math saying, yay, there's an answer, because we're not thinking about the rules of what's legal and what's not. We're just used to solving. Sometimes when you put in a math process to solve, like a squared or a square root, not addition or subtraction, multiplication or division, but with squares and square roots, sometimes by canceling out the square root, we allow an illegal answer in. He kind of like sneaks in the door. An illegal answer, literally, he sneaks in the door and says, hey, I'm right, and you're like, ah. And you go back to the Bible and like how you're supposed to beware of in the church, wolves in sheep's clothing, like they hide and they pretend like they're all on board, but really underneath they're not. Same thing here. The math says x equals 4 is right, but how do we make sure that it's not? Well, I'm going to go ahead and show you today in the lesson, but the long story short is check. If you check the answer, if it's illegal, let's check it. If I was to square root 4, does that equal negative 2? And the answer is?
No.
No, that's a positive 2, which is not negative 2. So when I tried to check, I realized it didn't work. And so then I say, this is an extraneous solution. So as we, Diego's on your phone, better not be, put it away.
Is that all for the section?
Here we go. This is the one bit of notes I need you guys to take. This is it. This little blurb. This little blurb. And then we have 2 examples. I don't know, blurb is like a little like just a couple words, a couple sentences. It sounds like it's from the back of the book. I actually don't know if it is. Oh. Okay, write it down word for word. Don't waste time. Extraneous. It's a word that you're going to see in directions. And what it means is a solution. So a solution means the math is saying it's a solution. The math is saying there's a solution. It comes out of our solving process. Like when we put the squared, we got that answer in the last example, but it's not valid. It sneaks its way in. And it's just something with the math that we're doing kind of harder math than addition and subtraction, multiplication, division. And by ignoring the roots, by not considering what we would call domain restrictions, we allow in something that is basically illegal. So, we're going to have to check. We're going to have to check because we might get only one answer and it's right and we're done. We might get only one answer and it's wrong, so no solution. We might get 2 answers and one of them is good, keep it. The other one's extraneous or illegal or wrong. Okay, throw that one away. So we're going to have to check our solutions, our answers. Now the nice thing is homework in that last part, 45 to 55 odds. Homework starts by just saying, hey, are any of these extraneous solutions? They have another AP back there. There was calculus and well, Alright, so then coming back. We need to start with which solution, if any, is extraneous. Okay? Which solution? So I'm going to go ahead and zoom in on the example. Kiddos, they're already saying, like, hey, guess what? If you already solve, you might get this answer and that answer. Can you check and see which ones are good? Maybe both of them are good. Maybe neither of them are good. Maybe one is good and one is not. Okay, Kaylee, give me
Oh,
1 second just to
no,
start
no,
the example.
I got it.
So all we need to do for the first part is literally plug it in and check. So plug it into what? The original equation. So we're gonna plug in first y equals -1. We're gonna plug into the y. And the y shows up in this equation in 2 spots. Do you guys see where the y is in 2 spots? So plug in the -1 there, the -1 there. Now we need to simplify and say, is this true or is this not? The equal says yes, but if it doesn't work, you say, no.
Once you get lucky, you get the first.
So PEMDAS, look underneath. We multiply first, which is -2 plus 3.
Which is,
Then we go ahead and say -2 plus 3 is 1. So we have to ask ourselves the question, is the square root of 1? So the square root of 1?
Easy only.
Potatoes and bananas? Okay. Is the square root of 1 -1?
That's my dream.
I know it's hard to share with the high schoolers, but you got it with the older ones with the higher math.
Everybody out was easy.
Gerardo, if you can just take everyone out and make them be quiet. I'm sorry, guys, I have to finish this class here. But I love you all, and I'm glad you're alive. And I'm sorry for the potatoes and the bananas. Okay, bye. Diego, you want me to do this? Close the door. Okay. Guys, here we go. I know it's hard. Remember, this wasn't the plan at the beginning of the year, but we're doing what we need to for me to help you. Okay, here we go. Is the square root of 1 -1? Yes or no? So therefore, this is an illegal solution, an extraneous solution. Okay?
now for 3.
Now for 3. You can do math, and it looks as though it works, but the square root of 1 cannot be it. See what I mean?
3
Yeah,
works.
it's a struggle. It's a struggle. So we have to check both sides. So extraneous, so far what we have, y equals -1 is extraneous. It's not valid. We wouldn't actually use it as an answer. If we were to plug in 3, I'm going to go pretty quickly, but 2 times 3 plus 3 equals -. Oh, no, we have to plug in 3. Good. So we have to plug in for 3. 3 there, and 3 there as well. 2
Turns out
times
to be 9,
3 is 6. 6 plus 3 is 9.
and then that's 3.
Is the square root of 9 positive 3?
Yes.
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 Oh,
So since that is true, that is not extraneous. That's a good solution. So when they ask us which are extraneous, they're asking us for the bad solutions, the ones that don't work. Does that make sense?
Wait. So, wait, what do you mean? What do you
So
mean?
since this was false, I'm going to put a little X. Since this was false, he's called an extraneous solution.
So
He's an illegal solution that snuck in. Now, they didn't even have a solve for him. They just had his check. We plugged in and said it doesn't work. He's extraneous.
we have to just find the positive.
We plugged that in. It works. So he's not extraneous. He's good.
Would they all? Okay, would a negative number always be fine?
Not necessarily. But we can look at this once we start homework. Angel, if you have any questions. One more example. Nope, wait until we finish notes. Solve the equation. How can we solve this equation? Problem.
For these problems, we use a radicand.
We can't just use the radical, but we do need to look at that radical and see that it's there and say, oh, we gotta get rid of that radical.
Parentheses. Put the parentheses and then put the square.
Yeah, we can put parentheses on both sides, we can get rid of that radical. So if we put squares on both sides,
What do you
hold
mean?
on. We put squares on both sides, we need to get rid of the radical. It's gone now, right? And we get x plus 6. On the left, x is now squared. Okay, this is a bit of a dilemma to this. In that we now have to solve a quadratic, which is problem 9. Now, to solve a quadratic, we do have lots of options. I know a lot of you guys, I'm just moving everything to one side.
True.
A lot of you guys like the quadratic formula, if you keep it memorized, because you at least know what to do. I'm going to go ahead and model this one though, not the quadratic formula, not the ABC. I'm going to model factoring. Because factoring in this one is pretty easy, because if we're looking at factors of
I got the other X word. crossed out
negative
too.
6
Number.
that sum to be negative 1. This is an easy chart because there's not a number on the far left. Factors of negative 6 that sum to be negative 1. Can anybody think what times what makes 6?
Negative 3 and 2.
That's only one apart. 3 and 2, but if I need the sign to be negative,
So you gotta, it's negative 3.
I need a negative 3 and a positive 2. So I'm going to go ahead and put a negative by the 3, which means I can go ahead and make factors of x minus 3 and x plus 2. Now the nice thing is guys, after we get past this class, chapter 10, we're going to have a week and a half for review. Factoring is going to be one of those days. Because now that you guys have seen it and done it a little bit, once you've seen it and done it a little bit, maybe I can show you some shortcuts about how to maybe factor a little bit faster. But for right now, factoring is one way that you could have gotten here. You now need to set each one equal to 0. Some of you know how to shortcut this, some of you don't. When we set equal to 0, what are the two answers that I
3
get?
and negative 2.
3 and negative 2. Our test is on Tuesday, it's on the calendar. Okay, now here's the problem, kiddos. We did all that work and we found 2 solutions, but the problem is one of them might be extraneous. So what do we need to do? Check. Because of the math that we did, we might have let an illegal one in. And it's not our fault, it's just the way the math has limitations. So we're going to plug in x equals 3, and we're going to plug in x equals negative 2. If I plug in x equals 3 to the original equation before anything happens, so the x equals square root of x plus 6,
Oh, that works.
we can say, Johnny's already plugging it in his head, and that's good, but we gotta double check. 3 equals square root of 3 plus 6. Is 3 the square root of 9? Yes or no?
Yes.
So is this a good solution? Yes. If we plug in negative 2, negative 2 plus 6, can a negative come out of a square root? If you put square root of 4 in your calculator, is that a positive number or a negative number? It's a square root.
It's positive.
It's always a positive. So the square root of 4 is positive 2. That's if we're solving and we put in the square root. If we put in the square root, we can make it plus minus. But if it's given to us, there's no minus. We have to assume it means only positive. And it does only mean positive. Jordan.
Are there going to be any answers you need to know if there's
Could be, especially if there's only, say, one solution, like it's not one of these where there's 2, and let's say that one solution doesn't work, there would be no solution.
Well, I did for 45, I just did it, and like I plugged in both 5 and 1, and they're both like, they both work.
I would double check your math real fast, but it's possible that there are 2 answers. It's possible that there's one answer, and it's possible.
I'll look at the back of it.
Harder to self-define it on the test, or you're going to be given closer.
You need to know what we cover in class on the test, so it's a yes in the sense of anything that we're covering will be on the test, and we'll see it in the review. I'm going to go ahead and show homework to you, kiddos. I want you to write down homework. We do have like 5 minutes. I can do more examples, but if you want to work on homework, number 1, you need to get this written down or a picture taken. You need to get this written down or a picture taken. If you have your book, you may start homework if you feel so inclined. I'm going to have you stay in your desk to save you time and let you get more done. Just stay in your desk, don't move around. Yes. If you're going to work on homework, you may listen to me. However, I do have 2 more examples I can do that might help you with homework. So if you're like, I'm not going to do homework, then you need to pay attention to what we're doing. Don't use 2 and 2, use 4 and 2. If anybody has, listen, Caleb. If anybody has homework number 61, I'm going to do 2 more examples. So only the people that are like, I want to do my homework and I'm going to do it, you may listen to music and you may be working on homework. So if your book's not out, then music is gone, you're listening to the last 2 examples. If you have homework 61, we're going to pass it back to Barry, who's going to put it in the tray. So it'll be all nice and safe. It's technically not due until tomorrow, so if you need it until tomorrow, you can wait. 61 and 62, we're turning in all of 10-3 officially tomorrow. If it's done right now, pass it back. If it's done right now, pass it back to Barry. If it's not done right now, you can wait until tomorrow. Alright, kiddos, let's finish strong. Alright, kiddos, let's finish strong. If you're working on homework, great. Just tune me out, work on homework, and if you get stuck, you can ask me a question once the bell rings, like at the beginning of lunch. If you're not working on homework, I expect you to at least pay attention to the last 2 examples. Okay, if you don't have your book, you're listening to the examples. You can only be distracted if you don't have your book. Okay. I'm going to go ahead and actually do number 2, because we've already done one like number 1. I'm going to do number 2, because we've already done one like number 1. In number 2, if you're not working on homework alone and quietly, you should be listening to me. In number 2, I see my radical. But I have a plus 10 that's also there. So like what we did in the warm-up today, or that challenge problem, we got to get rid of the 10 first. Is that good so far, my ones that are listening? Get rid of the 10, Okay, so we're going to get rid of the 10. We have the square root of 3n equals, careful, 1 minus 10 is?
negative 9. And we
At
square root
the
to 9.
if you notice from earlier in class, whenever we have a square root and a negative, in class we were like, oh, that's impossible. So to be honest, you could almost skip down to no solution right now. But if you didn't see that, if you see a square root equaling a negative, that's never going to work. But if you don't see that, you should have squared both sides. And when you square both sides, the square root and the square cancel.
I had always thought like also the square root on the other end of the cancel too.
No, only when there's a radical and a square root. On the other side, negative 9 times negative 9 is positive 81. We can do that.
Yeah.
And we can divide by 3. We can divide by 3. And we get, now if you went to your calculators or if you did long division. Good, 27. Now, this is what we think the answer is. But the problem is, whenever we use a square, we might have let an illegal one in. So we have to go ahead and check. And say, okay, when we check m equals 27 in the original equation, is the square root of 3 times 27 plus 10 equal to 1? Well, to help you out real fast, 3 times 27 is actually 81, as we kind of saw earlier. And we can do the square root of 81. Remember, we're asking ourselves, is this true? What's 9 plus 10? Not 1. Do you see why this is a no and this doesn't work?
I think I saw the whole thing.
Oh, no, you can't solve the whole thing. You can keep going. Does 19 equal 1? Does that make sense? So we say the solution, what's that snazzy word to explain him? The answer is no solution. The name of this guy is extraneous. That's the adjective. He's an extraneous solution. Yeah. Now, that means you did really good math up until that point, but whenever we put in a square, we might let someone illegal in, so we have to check first.
Normally, if the negative on the other side, it's always going to be less than
I'm not going to go through and do this one because class is almost over, but I want to let you know this example is a lot like the one we did in the notes in the page before, where you square both sides and you have a quadratic that you need to solve, maybe with quadratic formula, maybe with factoring. As we review for our final, we will get better at both of these. Kiddos, thank you for your attention today. Just hopefully so you realize when we're quiet and when we focus, we get work done, and life is just so much more efficient. Bye, cool kids, homework 62 for tomorrow. If you did not write it down, take a picture, it's chilling.
Thank you. When is Jeff coming back?
Forgot.
Exactly.
Alright guys, go get lunch, go get lunch.
Thank you.
We're not gonna do that.
Bye buddy. Take those notes at home, okay?
They're like the exact same